Okay, so today I want to talk to you about Darwin Core. Darwin Core is a standard that facilitates the sharing of biodiversity data. It consists of Darwin Core terms, which are a set of commonly defined terms with descriptions, and a Darwin Core Archive, which is a file structure which you can use to publish your data in a way that makes it a lot easier for someone to reuse them in the future. Before I show you exactly how all this works, I first want to show you exactly why you should want to follow the Darwin Core standards, and why that's going to be useful for you as a data creator, but also for the person who's using the data at the other side. So let's hop over to my PC and we'll have a look. So the biggest collection of data published using Darwin Core terms and Darwin Core Archives is hosted by GBIF. So GBIF stands for the Global Biodiversity Information Facility. It's a collection of more than 2 billion occurrence records, where a single occurrence record is a single observation of a single specimen, or perhaps a group of specimens of the same species. I should also give a shout out to OBIS, who are the Ocean Biodiversity Information System. Now, OBIS hosts data only for marine life, as the name suggests, whereas GBIF hosts data both for marine and terrestrial life. But if you publish your data to one of them, they share their data amongst each other, and so for the data user you can access the same data set, as long as it's marine, from either GBIF or OBIS. So for you as the data creator, it doesn't really matter which of these data centers you publish your data to. But I'm going to focus on GBIF today. So let's say I'm into birds, for example, and I want to find some data about the snow bunting, which is the only songbird that we get up here in Svalbard. So I can go to Google and I can look for what the scientific name is for snow bunting, which is here, Plectrophenax nivalis. I'm going to copy this and I can go back to GBIF, and there's a lot I can do here, but I'm going to look for species. So if I go to the search bar at the top, I can paste in my Plectrophenax, the snow bunting scientific name, and hit search. And I'm going to click the first one at the top, which also has the author name, which is correct to the species I'm interested in. So look at this. I have this cool little map where I can see where snow buntings have been observed across the planet, and I can quickly filter by the date as well. But if I want to do some really cool stuff, I can hit Explore here. And then I go to Map. And you can see we return this much higher resolution map with all our occurrence records here. So here we can see there are almost 650,000 different occurrences here. And the important thing to note is this isn't just one data set. This is a collection of all different data sets, displayed and accessible through one single data access point. So let's say I want to get a quick idea of how their migration patterns take place. I might want to filter by the month of the year, for example. We know they're only here in Svalbard in the summer months, so perhaps I want to know where they are in January and February, and we can quickly have a look at this. And of course there are a whole host of other things you can filter by, particularly if you open up this advanced filter options at the top. So you can go through here and filter for whatever you're looking for, and then you can hit download here. I already have an account, so I'm going to continue through Facebook. And you can see I'm directed to this page where I can download the data that I've filtered for. And this is where things start to get really cool. So there are 3 different formats we can use to download the data. We can download the data as a Darwin Core Archive, which is a format that all of these data will have been provided in. And that will include all of the metadata and all the raw data that is included. We can also download the data as a species list, which is not going to be very interesting in this case because we're only downloading data for one species here. But in this case, I'm going to download the data as a simple tab delimited CSV file, which you can open in Excel or whatever software you want to use for your CSV files. So we're redirected to this page. This takes a little while to download. This is a big collection of data that's been harvested together into a single data set. And then when this is finished, we'll be sent an email and we can download our data through the link. But in the meantime, I can show you a couple of things. we can see that the data that we've downloaded has been assigned a single citation that we can use if we're using the data in any papers that we're going to publish. This citation includes a DOI, which is unique to the dataset that we've downloaded. But what's interesting here is this is a single DOI for all the data, and we know that this data is likely a collection of a lot of different datasets. So we have to think of this DOI here as the parent DOI. So let me show you what I mean by that. If we go back a few pages, and I can have a look at which datasets have contributed to this data collection. So we have, for example, the Norwegian Species Observation Service. I'm going to copy this name here. And I'm going to go back to GBIF's homepage. So if I go into this time datasets and search here for the Norwegian Species Observation Service, and I can find it here at the top. We can see this is actually 27 million different occurrences, some of which are snow bunting that have been recorded all over Norway. And we can see here that this dataset actually has its own DOI. So this is like the child DOI. So the DOI that you're given when you download the data encompasses all the different datasets that contribute to that single data collection. So each of those children DOIs, if you like, will have the same parent DOI. And it's still possible to acknowledge each of those datasets individually. So if we go here to the top right, we can see that this dataset has been used in 733 different publications. So we can click on this, and we can see all the literature that have used this dataset. So this is a really neat way to encourage people to publish their data, no matter how small their dataset is. If their data are going to be found in one of these filters and included in the same dataset, that dataset is going to be cited and given the acknowledgement, whether it is a single record or perhaps 10,000 different records that are being used. So this is a really good thing for you as the data creator. It doesn't matter how small or insignificant you think your data might be, there's the opportunity here for them to contribute to something that's much bigger and much more significant. So now let's see if the data are ready. So I've received this email here. I can download it using this link. And if I open up this zip, we can see it includes a single CSV file. So here are the data ready for us to analyze however we want. But this is only possible if your data are published in a certain way. So there are three things we can consider here. Firstly, your data have to be self-describing, so both a human and a computer can understand exactly where the data are within the file and where the metadata are within the file. Secondly, your data has to be published with rich metadata, and some of that metadata needs to be common to every single file that's contributing to your data collection. So things like the coordinates, the time that the data was collected, who's the author of the file. These are things that someone might search by when they're trying to look for the data, or might filter by. So these are what we call discovery metadata. They help someone to find the data. But we also have use metadata, which allows someone to use and understand the data. So things like the units and the parameter names, for example. And the third thing is that all these metadata terms and all these parameter names have to be taken from a controlled vocabulary. So a controlled vocabulary is like a set of terms which have been commonly agreed upon, and so everyone uses the same terms, and they've been accompanied by a description, and that's posted online so someone can find the term and understand exactly what's meant by that. So in this case we have Darwin Core Archives and Darwin Core Terms. Okay, so finally, let's talk about what a Darwin Core Archive is and how you can make one. So the first thing you should know is that a Darwin Core Archive isn't a single file, it's actually a collection of files that are zipped together into an archive. And each of those individual files is actually quite simple. So the first component of a Darwin Core Archive is a CSV file, and that's in the core of the file, so we call it a CSV core. And there are different types of cores, but in this case we're going to start with a simple example where we have an occurrence core. So a single row in this file is going to be a single occurrence. So that could be a single observation of an individual or a group of individuals, each of which are in the same species, and you state how many you've seen. And remember column names, each of these are then Darwin Core terms. Another thing I should mention is that each row in this file has its own ID, and since this is an occurrence core, we're going to call that an occurrence ID. So according to Darwin Core, the best practice is if this ID is unique not just within the file, but also is universally unique. So you could use a universally unique ID, for example, or a UUID. This ensures that we have a way of reliably identifying every single row within the file, and I'll go back to exactly why it's important to be able to do that in a little bit. The other components of a Darwin Core archive are two XML files, where XML stands for Extensible Markup Language. If you don't know what that is, don't worry. I'm going to show you a very easy way to create these files without any knowledge of what an XML file really is at all. So the first one of these files is called a meta.xml file. So if we open this up, what we can see is this describes the structure of the file, how all the data and the metadata are laid out in a way that a machine can read and understand. So I don't want to go into too much detail, but we can see here, for example, that we have different numbers for each of the column numbers, and then we have a URL that links us to what each of those terms is. So if we are to follow one of those URLs, we will find the Darwin Core term and a description. So if someone picks up this Darwin Core archive, they can follow this link and they can understand exactly what is meant by the data within that column. But also importantly, a computer should also be able to understand what each column contains. And then we have this other file, this eml.xml. So EML is the ecological markup language, and this describes the data set as a whole. So things like who's involved in collecting the data, a title, and so on. Okay, so let's move on from that simple example, and I'd now like to talk on to what I think most scientists should be using whenever they can, and that is using an event core. So in an event core, each row is a single sampling event. So each row will also have its own event ID. And then, as well as that, you have an occurrence extension, which is another CSV file. But why would we want to do this? Wouldn't it just be easier just to dump everything in one file? Well, organizing our data like this allows us to map many-to-one relationships. So let me give you an example. Imagine each row in our CSV core is a single sampling event. Perhaps we have different casts of a net at different times and different locations. Imagine in the first cast of a net we catch two different fish. We can record each of those fish as different rows in our occurrence extension, and each of those rows will include the event ID in an event ID column of the sampling event that fish was caught from. So we can include all the information about each sampling event in the sampling event core, and we don't have to duplicate that information in each row alongside each occurrence. So this is a much more efficient way to record information. Another thing is you might want to include some physical properties as well. So for example, the temperature of the seawater. Now, if you want to include this in an occurrence core alongside each occurrence, it might be ambiguous as to whether you're referring to the temperature of the seawater or the temperature of the specimen. Now, this might sound like a pedantic point, but whilst humans are good at distinguishing between things when the situation is ambiguous, machines are not. And so it's best to be explicit where we can. So now we have these two CSV files, an event core and an occurrence extension. But we could have any number of extension files. So for example, we could have a measurements and facts extension, which admittedly could have a more catchy name. But what this would include is different measurements that we've taken of each occurrence or from each event. So let's say we take some measurements of the weight of the fish or the length of the fish. We can include all these in here. And in this case, we would have three different ID columns. we would have the event ID, which is the sampling event the fish was caught in, the occurrence ID, which is the ID of the fish, and then we would have the measurement ID, which is unique to every single measurement. Measurements like this are handled a bit differently in Darwin Core. So for example, you have a measurement type column, which would include, for example, fork length, which is the length of the fish. You could have then the measurement value, which could be 30 or 40, and then the measurement units, which would be centimeters in this case. So we have this central CSV core that's surrounded by each of these CSV extension files. And we call this the star schema. And the key thing to remember here is that each of these CSV extension files needs to be linked back to the CSV core using the IDs. Now, you'll be happy to know there's an easy way to create all of this and it doesn't require any coding whatsoever. So, firstly, you can create each of these CSV files using templates or template generators. And then you can create the XML files and zip it all together using GBIF's Integrated Publishing Toolkit, or IPT. So for the templates, I'm going to give you two options. The first option is you could use a Nansen Legacy template generator. I recently did a big video on this, so I'm going to just put a link to that in the description, and if you want to have a look at that, you can go and find it. And the other option is that GBIF actually have their own templates, and you can go and download them. So the Darwin Core templates that GBIF provide are available on their website, and I'll put a link to where you can find them in the description. But here they are, and if you go down, you can click on the sampling event data. And we have a bit of an introduction here that tells us a bit about when we should be using this type of template. If we scroll down, there's then some information about how you can transform this data into sampling event data. You can download different examples of a template, one empty and one with some example data within. And it tells us about which columns we should be including, which are required, which are recommended. And you can use any of the other Darwin Core terms within these templates too. You just have to create a new column. And then we have the Integrated Publishing Toolkit. So this is what you're going to use to create your XML files. There's a map here of 314 places where this IPT has been installed. So you can click around on the map and find the nearest one to you. If you get in touch with them, you should be able to set up an account for you to use on their IPT. I've put a link to this page in the description, and if you scroll down, what you'll see is that there's a 25-minute demo which shows you step by step how to use the IPT. So I'm going to keep this quite brief. You can go ahead and watch this. So I'm just working with a test node of the IPT, so what you'll be working with will look a little bit different. But I'm going to scroll down here, I'm going to create a new resource, I'm going to give it a name. And then I'm going to create a sampling events type resource. And we can see some different sections here. So first we have our source data, and we can just upload a file that we want. This is going to be each of the CSV files that we've created. This could also be from Excel, so an XLSX file or whatever. The next bit is then the Darwin Core mappings, and so this is where you map each of the Darwin Core terms to different columns in your templates. Now, if your template already has Darwin Core terms, you don't have to do anything here. This is done semi-automatically for you. But then if you have any remaining columns, for example, if your Darwin Core term has been misspelled, or you've got another column that you've called something else, you can go through and map it to the correct term here. You can then go to metadata, and this is actually just like filling in a form. You have each of these sections on the side. You might not have to fill all of this in. There's different asterisks to say whether this is a required term or not. But all of this goes into the eml.xml file that we talked about earlier. So go through this and fill it in and hit save. And then finally, at the bottom, if you want to publish this directly to GBIF, you can hit publish here. Now for most of you, it's as simple as that. But if you want your data to contribute to SIOS, for example, if you're in Nansen Legacy, GBIF and OBIS don't actually contribute to SIOS. But fortunately, we have a bit of a workaround. What you can do is publish your Darwin Core Archive privately. Only you will be able to see it. This isn't really publishing your data. You then download that Darwin Core Archive and publish that with a data center that does contribute to SIOS. Again, I've put a link to where you can find a list of data centers that contributes to SIOS in the description. So once you've published it with that data center, they will assign a DOI to your dataset, and then you can come back to GBIF and publish the same Darwin Core Archive with them using the same DOI. And because you've assigned the same DOI to the data in both data centers, anyone will be able to identify these data as duplicates. And perhaps just as importantly, a computer will also identify these data as duplicates. So now all that's left for me to do is thank you very much for watching. See you next time.